In example 1, we have a handful of polynomials, and for each one, we're going to decide whether or not it is in standard form, and if not, we're going to write it in standard form. We're going to identify the degree of each polynomial, its leading coefficient, leading term, and constant term. So we're just practicing some of the vocabulary that we encountered on the first page. Okay, so example 1, the directions say to complete the following table for the given polynomials. So the first polynomial we have is 4x minus x to the third power. Okay, again, we have powers of x that we are adding or subtracting, or just numbers. None of the powers of x are fractional. None of them are negative. There's no fractions. There's no absolute value. There's no radicals. Okay, so it fits the bill of a polynomial. Okay, is it in standard form? Well, the answer is no. Remember, standard form means that it has to be written with descending powers of x as you go from left to right. Okay, so we're going to write it in standard form, so we just need to rearrange it. Okay, there are two terms in this polynomial. There's 4x, and then there is negative x cubed. Okay, so two terms. So the highest power of x needs to go first, so the x cubed term needs to go first. You need to take the negative sign with it because the negative sign belongs to the x cubed. Okay, and then we're going to write the 4x. It is positive. Okay, so to write this in standard form, it is negative x cubed plus 4x. Okay, the degree here is 3 because the highest power of x is 3. Okay, the leading coefficient, that's the number in front of the highest power of x. Well, the highest power of x is 3, and so the number in front of x cubed is negative 1. So that's the leading coefficient. The leading term, now make sure you understand the difference between the leading coefficient and the leading term. The leading term is the actual piece. Okay, so this is a term, this is a term. Okay, so the leading term is the term with the highest power of x. So the leading term is negative x cubed. The leading coefficient is the number in front here. It's the number in front of the highest power of x. So it's essentially the number associated with the leading term. Okay, finally, let's write down the constant term. Okay, there isn't one because both of these terms have an x. So you can just write 0, I guess, because essentially this is plus 0. Okay, so I would accept none, or if you wanted to write 0, that's fine as well. Okay, all right, next polynomial, 5x to the 4th power minus pi times x cubed plus 1/2. All right, so don't be freaked out by pi. Pi is a decimal that it is approximately 3.14. Okay, it's just a number, so this is really a number times the power of x. Okay, also don't be alarmed by the 1/2 here. The 1/2 is a fraction, but there's no x in it. Okay, 1/2 is the same thing as 0.5. It's just a number. Okay, so this is a polynomial. It is in standard form. Okay, we have descending powers of x. We go from the 4th power to the 3rd power, and then there's no x here. Okay, so it already is in standard form, so I'm just going to rewrite it. And then the highest power of x you see in the whole thing here is the 4th power because we have x to the 4th. So the degree is 4. I'm going to go ahead and write down the leading term first. I probably should have put that first. How many terms do we have here? We have 1, 2, 3 terms in this polynomial. So 5x to the 4th is a term, negative pi x cubed is a term, and 1/2 is a term. The leading term is the term that contains the highest power of x. So that's going to be 5x to the 4th, and then the leading coefficient is the number in front of the highest power of x. So it's 5 here. Okay. The constant term, we actually have one here. It's just the number, so it is 1/2 or 0.5. Okay. Something I keep forgetting to mention. Notice, if you have in a polynomial, you don't have to have every single power of x. Here we have a 4th power and a 3rd power. We don't have a 2nd power or a 1st power, and that's okay. You don't have to have everything in between. All right, moving on to the next one. Okay, 2. Okay, well, I don't know. Is this a polynomial? Well, yeah, it is, because remember, I told you you need to be adding or subtracting powers of x or just numbers. You can have just a number. Okay, so this is a polynomial. It's got one term, the 2, and so it's already in standard form. The tricky thing here is, what is its degree? The degree is the highest power of x, and you don't see an x. So you're probably like, well, none. Okay, well, here's the deal. Okay, this is how they trick you in math. Okay, this is the same thing as 2 times x to the 0 power. Okay, if you've seen this before, anything to the 0 power is 1. So really, this is 2 times 1, which is 2. Okay, so that's why technically this is a polynomial, because it's really a power of x. It's just the 0 power of x. Okay, so the degree of this particular polynomial is 0. Okay, anytime you have just a number as your polynomial, its degree is 0, because it's the number times x to the 0 power. Okay. All right, so if we're looking at this as 2 times x to the 0 power, the leading term would be 2, or you can write 2x to the 0. It's up to you. The leading coefficient is going to be 2, and the constant term is going to be 2. 2 is everything, because it's the entire polynomial. Okay, so I just wanted to make sure you understood that just a number is a polynomial. It's a 0-degree polynomial. Okay. All right, here comes the next one. Okay, when you look at this, x minus 1 quantity times x plus 2 quantity times x minus 3 quantity. Okay, you have these 3 factors. Factors are things that you're multiplying together. That's what you have. 3 factors multiplied together. Is this a polynomial? Okay, well, the answer is it is. Okay, so here's the deal. It's not in standard form. Okay, for it to be in standard form, it needs to be written like a number times the power of x plus or minus a number times the power of x plus or minus a number times the power of x, and so on. Okay, so what we can do here is actually multiply this out. Okay, that's what we have to do if we want it in standard form. So the correct way to multiply this out, think of multiplying 3 numbers. Okay, we don't distribute. We don't send the 4 to the 5 and send the 4 to the 6. Okay, we combine them 2 at a time. So like we do 4 times 5 is 20, and then we do take that result and multiply it by 6, and we get 120. Okay, so we're going to do the same thing here. Okay, so I'm actually going to start, when you multiply, it doesn't matter what order you multiply in. I'm going to start by multiplying the x plus 2 times x minus 3. So I'm going to box this thing. Okay, so here we go. This is going to give us, let's see, x squared minus 3x, 2x, and then negative 6. Okay, so I'm going to go ahead and write down the result of multiplying these two guys in yellow. We're going to get x squared, and then the minus 3x combines with the 2x. That's going to be minus x minus 6. Okay, and then we need to take that result and multiply by x minus 1. Okay, so I'm going to do another boxing here. So I'm going to do x minus 1, and then we just need to go across x squared minus x minus 6. Okay, so it's just going to be more boxes. So let's see here. We're going to take each pair, multiply them together. X times x squared is x cubed. X times negative x is negative x squared. X times negative 6 is negative 6x. Negative 1 times x squared is negative x squared, and then negative 1 times negative x is positive x, and then negative 1 times negative 6 is positive 6. Okay, so if we combine like terms and write them so that we have descending powers of x, okay, I'm going to write the x cubed term first, and then I'm going to write down all the x squared terms. Okay, so let's see here. We've got negative x squared and a negative x squared. Those guys combine to be minus 2x squared. And then if I keep going, I'm going to combine the negative 6x with a positive x. That's going to be negative 5x. And then I've just got the number, which is positive 6. Okay, this is what this polynomial looks like in standard form. Okay, once you multiply it out, it looks more like a polynomial. Okay, all right, so we've got descending powers of x. Everything's multiplied out and simplified. This next column was for the degree. The highest power of x you see in the whole thing, it's easier to look at the multiplied version, is 3. And then the leading term. Okay, we have 4 terms here. X cubed, minus 2x squared, minus 5x, positive 6. The term with the highest power of x is x cubed. And then the leading coefficient is the number in front of that, which is 1. And the constant term is the piece with just a number, that is 6. Okay, so that's it for this one. Okay, all right, so one more polynomial. Okay, it is a fraction, 1 minus x squared over 2. Okay, even though it's a fraction, there's no x in the denominator, so it is considered to be a polynomial. Okay, it is not in standard form. Again, standard form, you want to see a number times the power of x plus or minus a number times the power of x plus or minus, and so on. Okay, so let's see here. Okay, to make this look like a polynomial, so to write it in standard form, okay, we're going to break up the fraction. The correct way to break up a fraction is to take each piece in the top and divide it by the entire denominator. So I'm going to take the first piece in the top, the 1, and I'm going to divide it by the entire denominator. So I'm going to get 1/2. And then I'm going to keep the same sign in the middle, so minus, and then I'm going to take the next piece in the top, so x squared, and I'm going to divide it by the entire denominator. Okay, so it's kind of starting to look like a polynomial. Okay, I'm going to rearrange it so that the x term comes first. So this negative goes with the x. Okay, so we've got negative x squared over 2, and then this is a positive 1/2. Okay, so now we've got descending powers of x. And then the last thing I'm going to do to really make this look like a polynomial, on this first term, you're dividing by negative 2. You've got negative x squared over 2, so you're really dividing by negative 2. If you're dividing by negative 2, that's the same thing as multiplying by negative 1/2. So we can also write this guy as negative 1/2 times x squared, and then plus 1/2. Okay, so now we've got a number times the power of x plus a number. It looks like a polynomial. So in standard form, this polynomial is negative 1/2 x squared plus 1/2. And as far as the degree is concerned, the degree is the highest power of x. Okay, the highest power of x is 2. And then we need to identify the leading term in this column. So the leading term is the term that contains the highest power of x. That's going to be negative 1/2 times x squared. So the number in front here is of this term is negative 1/2, so that's the leading coefficient. And then the last box here is for the constant term. The term that is just a number is the positive 1/2. Okay, and that is it.